Dear students, Visual Classes ਦੀ ਇਸ ਸੀਰੀਜ਼ ਵਿੱਚ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਇੱਕ ਵਾਰੀ ਮੁੜ ਕੇ ਸਵਾਗਤ ਹੈ। ਅਸੀਂ ਇਸ ਲੜੀ ਵਿੱਚ ਅੱਜ ਕੱਲ ਚੈਪਟਰ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਐਂਡ ਰੈਜ਼ਿਸਟੈਂਸ ਨਾਲ ਰਿਲੇਟਡ ਟੌਪਿਕਸ ਪੜ੍ਹ ਰਹੇ ਹਾਂ। ਅੱਜ ਖਾਸ ਤੌਰ ਤੇ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਅਤੇ ਇਸ ਦੇ ਯੂਜ਼ਸ ਪੜਾਂਗੇ। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰਸ ਵੀਟਸਟੋਨ ਬ੍ਰਿਜ ਦੀ ਹੀ ਇੱਕ ਪ੍ਰੈਕਟੀਕਲ ਫਾਰਮ ਹਨ ਅਤੇ ਵੀਟਸਟੋਨ ਬ੍ਰਿਜ ਕਿਰਚੌਫਸ ਲਾਅ ਦੀ ਇੱਕ ਐਪਲੀਕੇਸ਼ਨ ਹੈ। ਓਵਰਆਲ ਮੇਰੇ ਕਹਿਣ ਦਾ ਮਤਲਬ ਇਹ ਹੈ ਕਿ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਅਤੇ ਇਸ ਦੀ ਵਰਕਿੰਗ ਸਮਝਣ ਲਈ ਕਿਰਚੌਫਸ ਲਾਅਸ ਦੀ ਪੂਰੀ ਨੌਲੇਜ ਅਤੇ ਅੰਡਰਸਟੈਂਡਿੰਗ ਹੋਣੀ ਜ਼ਰੂਰੀ ਹੈ। ਸੋ ਮੇਰਾ ਖਿਆਲ ਹੈ ਕਿ ਜੇ ਮੈਂ ਜਲਦੀ ਨਾਲ ਇੱਕ ਲਾਅਸ ਤੁਹਾਨੂੰ ਯਾਦ ਕਰਾ ਦਿਆਂ ਤਾਂ ਚੰਗਾ ਹੀ ਰਹੇਗਾ। Well, Kirchhoff stated two laws to solve complicated circuits. His first law, also called as the Kirchhoff's junction law, states that the algebraic sum of the currents meeting at a junction in a closed circuit is zero. Kirchhoff's second law states that the algebraic sum of changes in potential around any closed path of electric circuit or a closed loop involving resistors and cells in the loop is zero. That is, sigma delta V is equal to zero. Before I start, let me first make you aware of the learning objectives of today's lesson.
After the completion of this lesson, the students will be able to describe a potentiometer and its principle, discuss the use of a potentiometer for determining the potential, discuss the use of a potentiometer to compare the e.m.fs of two cells, discuss the use of a potentiometer to determine the internal resistance of a cell, describe the sensitiveness of a potentiometer, differentiate between a potentiometer and a voltmeter.
आज ਦਾ ਟੌਪਿਕ ਸ਼ੁਰੂ ਕਰਦੇ ਹਾਂ। ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਹੁੰਦਾ ਕੀ ਹੈ? ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਮੈਂਗਨਨ ਜਾਂ ਕਨਸਟੈਂਟਨ ਦੀ ਇੱਕ ਲੰਬੀ ਯੂਨੀਫਾਰਮ ਵਾਇਰ ਦਾ ਬਣਿਆ ਹੁੰਦਾ ਹੈ, ਜਿਹੜੀ ਇੱਕ ਬੋਰਡ ਉੱਤੇ ਸਟ੍ਰੈਚਡ ਜਾਂ ਖਿੱਚ ਕੇ ਫਿਕਸ ਕੀਤੀ ਹੁੰਦੀ ਹੈ। ਕਦੇ-ਕਦੇ ਇਹ 4 ਜਾਂ ਇਸ ਤੋਂ ਵੀ ਜ਼ਿਆਦਾ ਵਾਇਰਸ ਥਿਕ ਕਾਪਰ ਸਟ੍ਰਿਪਸ ਦੀ ਮਦਦ ਨਾਲ ਇੱਕ ਦੂਜੇ ਦੇ ਪੈਰਲਲ ਫਿਕਸ ਕੀਤੀਆਂ ਜਾਂਦੀਆਂ ਹਨ। ਇਹਨਾਂ ਸਾਰੀਆਂ ਵਾਇਰਸ ਦੀ ਲੰਬਾਈ 1 ਮੀਟਰ ਹੁੰਦੀ ਹੈ ਤੇ ਇਹਨਾਂ ਦੇ ਐਂਡਸ 2 ਬਾਈਂਡਿੰਗ ਸਕਰੂਜ਼ A ਅਤੇ B ਨਾਲ ਕਨੈਕਟਡ ਹੁੰਦੇ ਹਨ। ਬੋਰਡ ਦੇ ਉੱਤੇ ਵਾਇਰਸ ਦੀ ਲੈਂਥ ਤੇ ਪੈਰਲਲ 1 ਮੀਟਰ ਸਕੇਲ ਫਿਕਸਡ ਹੁੰਦਾ ਹੈ। ਇੱਕ ਜੌਕੀ ਕਿਸੇ ਵੀ ਪੁਆਇੰਟ ਤੇ ਕੰਟੈਕਟ ਬਣਾਉਣ ਵਿੱਚ ਸਹਾਇਤਾ ਕਰਦੀ ਹੈ। ਇੱਕ ਬੈਟਰੀ E A ਅਤੇ B ਦੇ ਅਕ੍ਰੋਸ ਕਨੈਕਟਡ ਹੁੰਦੀ ਹੈ, ਜਿਹੜੀ ਡਰਾਈਵਿੰਗ ਸੈੱਲ ਕਹਾਉਂਦੀ ਹੈ। ਇਹ ਰਿਓਸਟੈਟ RH ਨਾਲ ਕਾਂਸਟੈਂਟ ਰੱਖੇ ਕਰੰਟ ਨੂੰ ਵਾਇਰ ਦੇ ਥਰੂ ਫਲੋ ਕਰਨ ਵਿੱਚ ਮਦਦ ਕਰਦੀ ਹੈ। Let me now tell you the principle of a potentiometer. The principle of a potentiometer states that the working of a potentiometer is based on the fact that the fall of potential across any portion of the wire is directly proportional to the length of that portion, provided the wire is of uniform area of cross-section and a constant current is flowing through it. Suppose A and rho are the area of cross-section and specific resistance of the material of the wire respectively. If V be the potential difference across the portion of the wire of length L, whose resistance is R, and I is the current flowing through the wire, then from Ohm's law we can write V is equal to IR. But since R is equal to rho into L upon A, it can be said that V is equal to I into rho into L upon A, or This is equal to K into L, where K is equal to I into rho upon A. Also, if I and A are constant, then V is proportional to L, where V by L is equal to K, equal to the potential gradient, that is the fall of potential per unit length of wire. So, principle of a potentiometer बारे चंगी तरह अंडरस्टैंडिंग हासिल करन तो बाद ਹੁਣ ਅਸੀਂ ਇਸ ਨੂੰ ਪ੍ਰੈਕਟੀਕਲ ਪਰਪਸਸ ਲਈ ਵਰਤ ਸਕਦੇ ਹਾਂ। ਇੱਕ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਮੇਨਲੀ 3 ਡਿਫਰੈਂਟ ਟਾਈਪਸ ਨਾਲ ਯੂਜ਼ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। ਅਸੀਂ ਇੱਕ ਕਰਕੇ ਤਿੰਨੇ ਯੂਜ਼ਸ ਬਾਰੇ ਪੜਾਂਗੇ। The first case that we are going to take up is to determine the potential difference using a potentiometer. I will like to show you a visual to help you to understand the circuit and its working.
Determination of potential difference using potentiometer. To do this, a battery of e.m.f. E is connected between the end terminals A and B of potentiometer wire with rheostat RH, resistance box R, and key K in series. This circuit is called an auxiliary circuit. The ends of resistance R1 are connected to terminal A and jockey J through the galvanometer G. The resistance R1 is connected to cell E1 and key K1 in series. To make this circuit work for the determination of potential difference, first close key K and adjust the resistance R from the resistance box so that the fall of potential across the potentiometer wire is greater than the potential difference to be measured. Then close the key K1 so that the current flows through R1. A potential difference gets developed across R1. The position of jockey is so adjusted on potentiometer wire that on pressing it, the galvanometer shows no deflection. Let this be the position with jockey at J. Note the length AJ of potentiometer wire. Let this length be L. It is so when potential across the potentiometer wire of length L.
ਹੁਣ ਅਸੀਂ ਇਹਨਾਂ ਆਬਜ਼ਰਵੇਸ਼ਨਸ ਨੂੰ ਯੂਜ਼ ਕਰਕੇ ਕੈਲਕੂਲੇਸ਼ਨਸ ਕਰਨੀਆਂ ਸਿੱਖਾਂਗੇ। If K be the potential gradient of the potentiometer wire, then potential difference across R1 can be written as V equal to K into L. If small r be the resistance of potentiometer wire of length L, then current through potentiometer wire is represented as I equal to E upon R plus small r. Thus, the potential drop across potentiometer wire is equal to V equal to IR equal to E upon R plus small r into small r. Now, the potential gradient of potentiometer wire, that is the fall of potential per unit length, is given as K equal to E upon R plus small r into small r upon L. Using the equation V equal to K into L, expression for V can be written as equal to E upon R plus small r into small r upon L into small l. So, I hope that the method of determination of potential difference using potentiometer is clear to you. Let us now explore some other applications of potentiometers.
Comparison of EMFs of two cells using potentiometer.
ਚਲੋ ਹੁਣ ਮੈਂ ਤੁਹਾਨੂੰ potentiometer ਦੀ ਵਰਤੋਂ ਕਰਕੇ ਦੋ ਸੈਲਸ ਦੇ EMFs ਕੰਪੇਅਰ ਕਰਨਾ ਦੱਸਦੀ ਹਾਂ। ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਇੱਕ ਵਿਜ਼ੂਅਲ ਦੀ ਹੈਲਪ ਨਾਲ ਇਸ ਨੂੰ ਸਮਝਣ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਦੇ ਹਾਂ।
Comparison of EMFs of two cells using potentiometer. You can see a circuit here. A battery of EMF E is connected between the end terminals A and B of potentiometer wire with rheostat RH, ammeter A and key K in series with the potentiometer wire. This circuit is called an auxiliary circuit. Two cells of EMFs E1 and E2 to be compared are connected to the circuit as shown here. The positive terminals of both the cells are connected to point A of the potentiometer. Their negative terminals are connected to terminals 1 and 2 of two-way key, while its common terminal 3 is connected to jockey through a galvanometer G. Then the key K is closed and a suitable constant current is adjusted in the potentiometer wire with the help of terminals 1 and 3 of two-way key, so that the cell of EMF E1 comes in the circuit. The position of jockey is adjusted on the potentiometer wire, so that when the jockey is pressed here, the galvanometer shows no deflection. ਮੰਨ ਲਓ ਕਿ ਜੌਕੀ ਦੀ ਪੋਜੀਸ਼ਨ J ਤੇ ਹੈ। ਵਾਇਰ ਦੀ ਲੈਂਥ AJ ਜਿਹੜੀ L1 ਦੇ ਇਕੁਅਲ ਹੈ ਉਸ ਨੂੰ ਨੋਟ ਕਰੋ। ਹੁਣ ਗੈਲਵੈਨੋਮੀਟਰ ਨੋ ਡਿਫਲੈਕਸ਼ਨ ਸ਼ੋ ਕਰ ਰਿਹਾ ਹੈ। ਇਸ ਕਰਕੇ ਆਮ AE1J ਵਿੱਚ ਕੋਈ ਕਰੰਟ ਫਲੋ ਨਹੀਂ ਕਰ ਰਿਹਾ ਹੈ। ਇਸ ਦਾ ਅਰਥ ਇਹ ਹੈ ਕਿ ਸੈੱਲ ਦੇ ਪੋਜ਼ਿਟਿਵ ਟਰਮੀਨਲ ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ ਪੁਆਇੰਟ A ਦੇ ਪੋਟੈਂਸ਼ੀਅਲ ਦੇ ਇਕੁਅਲ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਸੈੱਲ ਦੇ ਨੈਗੇਟਿਵ ਟਰਮੀਨਲ ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ ਪੁਆਇੰਟ 1 ਦੇ ਪੋਟੈਂਸ਼ੀਅਲ ਦੇ ਇਕੁਅਲ ਹੈ। ਹੁਣ ਟੂ-ਵੇ ਕੀ ਦੇ ਪੁਆਇੰਟਸ 1 ਅਤੇ 3 ਦੇ ਵਿਚਕਾਰੋਂ ਪਲੱਗ ਰਿਮੂਵ ਕਰੋ ਅਤੇ ਇਸ ਨੂੰ ਪੁਆਇੰਟ 2 ਅਤੇ 3 ਵਿੱਚ ਇਨਸਰਟ ਕਰੋ ਤਾਂ ਕਿ ਸਰਕਟ ਵਿੱਚ EMF E2 ਆ ਜਾਵੇ। ਹੁਣ ਫਿਰ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਵਾਇਰ ਤੇ ਜੌਕੀ ਦੀ ਉਹ ਪੋਜੀਸ਼ਨ ਫਾਈਂਡ ਕੀਤੀ ਜਾਵੇਗੀ ਜਿੱਥੇ ਗੈਲਵੈਨੋਮੀਟਰ ਦੀ ਡਿਫਲੈਕਸ਼ਨ 0 ਹੋਵੇ। ਇਹ ਤਾਂ ਪ੍ਰੋਸੀਜਰ ਸੀ। ਆਓ ਹੁਣ ਐਕਸਪੈਰੀਮੈਂਟ ਕੰਪਲੀਟ ਕਰਨ ਲਈ ਕੈਲਕੂਲੇਸ਼ਨਸ ਦੇਖੀਏ।
After having noted down the observations for the two lengths of the potentiometer wire corresponding to the two cells, it is now turn to use this information to calculate the comparative EMFs of the two cells. Let us get to understand that too. We know that the EMF of the cell E1 is equal to potential difference between the points A and B of potentiometer wire. That is, E1 is equal to K into L1. Let this be equation 1, where K is the potential gradient across the wire. Similarly, E2 is equal to K into L2. Let this be equation 2. Dividing equation 1 by equation 2, we get E1 upon E2 is equal to L1 upon L2. We name this equation as equation 3. ਹੁਣ ਮੈਂ ਚਾਹੁੰਦੀ ਹਾਂ ਕਿ ਤੁਸੀਂ ਇੱਕ ਅਨਯੂਜ਼ੁਅਲ ਸਿਚੁਏਸ਼ਨ ਬਾਰੇ ਵੀ ਸੋਚੋ। ਜ਼ਰਾ ਸੋਚੋ ਕਿ ਜੇ ਇੱਕ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਵਾਇਰ ਦੇ ਪੋਟੈਂਸ਼ੀਅਲ ਵਿੱਚ ਬੈਲੈਂਸ ਕੀਤੇ ਜਾਣ ਵਾਲੇ ਸੈੱਲ ਦੇ EMF ਤੋਂ ਵੀ ਜ਼ਿਆਦਾ ਫਾਲ ਆ ਜਾਵੇ ਤਾਂ ਕੀ ਹੋ ਸਕਦਾ ਹੈ। ਚਲੋ ਮੈਂ ਤੁਹਾਨੂੰ ਇਸ ਦਾ ਜਵਾਬ ਵੀ ਦੇ ਦਿਆਂ। ਇਸ ਕੰਡੀਸ਼ਨ ਦੇ ਚਲਦੇ ਇੱਕ ਬੈਲੈਂਸ ਪੁਆਇੰਟ ਆਬਟੇਨ ਹੁੰਦਾ ਹੈ। ਓਕੇ, ਅੱਜ ਡਿਸਕਸ ਹੋਣ ਵਾਲੀਆਂ ਗੱਲਾਂ ਵਿੱਚੋਂ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਦੀ ਇੱਕ ਐਪਲੀਕੇਸ਼ਨ ਹੋਰ ਬਾਕੀ ਰਹਿ ਗਈ ਹੈ। ਉਹ ਹੈ determination of internal resistance of a cell using a potentiometer. ਜੇ ਇਸ ਨੂੰ ਵੀ ਪਹਿਲਾਂ ਇੱਕ ਵਿਜ਼ੂਅਲ ਰਾਹੀਂ ਦੇਖੀਏ ਤਾਂ ਕਿਸ ਤਰ੍ਹਾਂ ਰਹੇਗਾ।
Determination of internal resistance of a cell using a potentiometer. You can see a circuit setup. This circuit is connected to find the internal resistance of a cell of EMF E. using a potentiometer. First of all, the key K is to be closed to maintain the suitable constant current in the potentiometer wire with the help of a rheostat RH. Adjust the position of jockey on the potentiometer wire, where when it is pressed, the galvanometer shows no deflection. Let it be when jockey is at J. Note the length AJ of the potentiometer wire. Let this length be L1. Now, e.m.f. of the cell E is equal to the potential difference across the length L1 of the potentiometer wire. Now, close the key K1 so that the resistance R is introduced in the cell circuit. Again, find the position of the jockey on the potentiometer wire where galvanometer shows no deflection. Let it be at J1. Note the length of the wire AJ1 and let it be equal to, say, L2. Then, potential difference between two poles of the cell V is equal to the potential difference across the length L2 of the potentiometer wire.
To get on with the calculation for finding the internal resistance of a cell using a potentiometer, we know that the e.m.f. of the cell E is equal to potential difference across the length L1 of the potentiometer wire. Therefore, we can say E is equal to K into L1. Let this be equation 1. Of course, here K is the potential gradient across the wire. Now, the potential difference between the two poles of the cell V is equal to the potential difference across the length L2 of the wire. Thus, V is equal to K into L2. Let this be equation 2. On dividing equation 1 by equation 2, we have E by V equal to L1 by L2. This becomes equation 3. It is already known to us that when a resistance R is connected to a cell of e.m.f. E, then its internal resistance R1 is given as R1 equal to E minus V upon V into R, which is equal to E by V minus 1 whole into R. Let this expression for R1 be equation 4. In equation 4, we substitute the value of E by V as equal to L1 by L2. Then we can write R1 equal to L1 by L2 minus 1 into R, which comes out to be L1 minus L2 upon L2 into R. Now, don't you think that if we know the values of L1, L2 and R, the value of the internal resistance of the cell can be easily calculated? ਅਸੀਂ ਅੱਜ ਇਸ ਲੈਸਨ ਵਿੱਚ ਹੁਣ ਤੱਕ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰਸ ਅਤੇ ਇਹਨਾਂ ਦੀ ਵਰਕਿੰਗ ਬਾਰੇ ਗੱਲ ਕੀਤੀ ਹੈ। ਜੇ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰਸ ਨਾਲ ਪ੍ਰੈਕਟੀਕਲੀ ਕੰਮ ਕਰਨਾ ਹੈ ਤਾਂ ਇਹਨਾਂ ਦਾ ਇੱਕ ਹੋਰ ਵੀ ਬੜਾ ਇੰਪੋਰਟੈਂਟ ਐਸਪੈਕਟ ਹੈ ਜਿਹੜਾ ਸਾਨੂੰ ਪਤਾ ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ। ਇਹ ਇੰਪੋਰਟੈਂਟ ਫੈਕਟਰ ਹੈ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਦੀ ਸੈਂਸਿਟਿਵਿਟੀ। ਆਓ ਤੁਹਾਨੂੰ ਦੱਸੀਏ ਕਿ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰ ਦੀ ਸੈਂਸਿਟਿਵਿਟੀ ਜਾਂ ਸੈਂਸਿਟਿਵਨੈਸ ਕੀ ਹੁੰਦੀ ਹੈ। The sensitiveness of potentiometer means the smallest potential difference that can be measured with its help. The sensitiveness of a potentiometer can be increased by decreasing its potential gradient. This can be achieved either by increasing the length of the potentiometer wire, or if the potentiometer wire is of a fixed length, the potential gradient can be decreased by reducing the current in the potentiometer wire circuit with the help of a rheostat. After having learnt so much regarding potentiometers, can we compare a potentiometer with a voltmeter? Let's try to coin the differences between them. The first difference is a potentiometer measures the EMF of a cell very accurately, while voltmeter measures the EMF of a cell approximately. Second, for a potentiometer, while measuring EMF, it does not draw any current from the source of the known EMF, whereas for a voltmeter, while measuring EMF, it draws some current from the source of known EMF. Third, while measuring EMF, the resistance of potentiometer becomes infinite. While measuring the EMF, the resistance of voltmeter is high but finite. The fourth difference is the sensitivity of a potentiometer is high, while the sensitivity of a voltmeter is low. Fifth point, a potentiometer is based on null deflection method, while a voltmeter is based on deflection method. And the sixth point, a potentiometer can be used for various purposes, whereas a voltmeter can be used only to measure EMF or potential difference. Let me repeat some very significant issues about potentiometers. You know that a balance point is obtained on the potentiometer wire if the fall of potential along the potentiometer wire due to the driving cell is greater than the EMF of the cell to be balanced. It is also to be noted that a balance point cannot be obtained on the potentiometer wire if the fall of potential along the potentiometer wire due to the driving cell is less than the EMF of the cell to be balanced. Remember that a potentiometer is an ideal voltmeter, as it measures the EMF of a cell very accurately, whereas a voltmeter measures the EMF of a cell approximately. Finally, the positive terminals of driving cell and the cell whose EMF is to be determined must be connected to the zero end of the potentiometer wire. Otherwise, a null point is never obtained. We'll now solve a numerical problem based on potentiometers. In the circuit shown here, the uniform wire AB of the meter bridge is 2 meters long, having a resistance of 20 ohm. If the bridge is in balanced state, find first potential gradient along AB and second distance AO of the wire. Here E is equal to 4 volts, R is equal to 30 ohms and RAB is equal to 20 ohms. Length AB be equal to small l equal to 2 meter, which is equal to 200 centimeters. The potential gradient along wire AB, which is equivalent to calculating the potential drop per unit length of the wire AB, is calculated by IR upon small l, which is equal to E upon R plus RAB whole into R by L. This turns out to be 4 upon 30 plus 20 whole into 20 by 200 volt per centimeter or 0.008 volt per centimeter. Let I dash be the current sent by the 3 volt cell through the combination of 2.4 and 0.6 ohm resistors, so that I dash through 0.6 ohm resistor is equal to 3 upon 2.4 plus 0.6 equal to 3 upon 3 or 1 ampere. In the balanced state, V is equal to the potential drop across 0.6 ohm resistor equal to I dash into 0.6 equal to 1 into 0.6 or V is equal to 0.6 volts. Now, L into 0.008 is equal to 0.6, or L equal to 0.6 upon 0.008 equal to 75 centimeters. There is one more problem I would want you to learn to solve. A resistance of R ohm is powered from a potentiometer of resistance R0 ohm. A voltage V is supplied to the potentiometer. Derive an expression for the voltage fed into the circuit when the slide is in the middle of the potentiometer. Let's analyze the circuit first. When the slide is in the middle of the potentiometer wire, only half of its resistance R0 by 2 plays its role between points A and B. If now R1 be the total resistance between points A and B, then 1 upon R1 is equal to 1 upon R plus 2 upon R0 equal to R0 plus 2R upon R into R0. That is, R1 is equal to R into R0 upon R0 plus 2R. Let this be equation number 1. Thus, the total resistance between A and C becomes R1 plus R0 upon 2. And the current in the potentiometer wire I is equal to V upon R1 plus R0 upon 2, or I is equal to 2V upon 2R1 plus R0. The voltage V1 taken from potentiometer is given as IR1 equal to twice V into R1 upon 2R1 plus R0. Using equation 1, we have V1 equal to twice V upon 2 into whole of R into R0 by R0 plus 2R plus R0 into R into R0 by R0 plus 2R. This gives V1 equal to twice VR upon 2R plus R0 plus 2R, or equal to twice VR R0 plus 4R. This is the desired expression for the voltage fed into the circuit when the slide is in the middle of the potentiometer. ਹੁਣ ਤੱਕ ਤੁਹਾਨੂੰ potentiometers ਅਤੇ ਉਹਨਾਂ ਦੇ uses ਬਾਰੇ ਚੰਗੀ ਜਾਣਕਾਰੀ ਦਿੱਤੀ ਗਈ ਹੈ। ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਟੌਪਿਕ ਨੂੰ ਜਲਦੀ ਨਾਲ ਸਮਰਾਈਜ਼ ਕਰਾਂਗੇ। So, may we look at the key points of today's lesson once again. The working of a potentiometer is based on the fact that the fall of potential across any portion of the wire is directly proportional to the length of that portion, provided the wire is of uniform area of cross section and a constant current is flowing through it. It can also be used for a comparison of e.m.fs of two cells using the equation E1 upon E2 is equal to L1 upon L2, where L1 and L2 are the two corresponding lengths of the potentiometer wires. To find out the internal resistance of a cell using a potentiometer, we can make use of the equation R1 equal to E minus V upon V into R, which is equal to E by V minus 1 whole into R. And now, get ready to answer some of my questions. My first question is, state the principle of a potentiometer. The answer is, the principle of a potentiometer states that the fall of potential across any portion of the wire is directly proportional to the length of that portion, provided the wire is of uniform area of cross section and a constant current is flowing through it. The next question is, define the sensitiveness of potentiometer. The answer is, the sensitiveness of potentiometer is defined as the smallest potential difference that can be measured with the help of the potentiometer. Another question is, justify a potentiometer is an ideal voltmeter. The answer is, a potentiometer is an ideal voltmeter as it measures the e.m.f of a cell very accurately. ਮੈਨੂੰ ਆਸ ਹੈ ਕਿ ਪੋਟੈਂਸ਼ੀਓਮੀਟਰਸ ਬਾਰੇ ਪੜ੍ਹਾਏ ਗਏ ਅੱਜ ਦੇ ਕਨਸੈਪਟਸ ਤੁਹਾਨੂੰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆਏ ਹੋਣਗੇ। ਲੈਸਨ ਤੇ ਪੂਰੀ ਅਟੈਂਸ਼ਨ ਦੇਣ ਲਈ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੀ ਕਲਾਸ ਤੱਕ ਸੀ ਯੂ ਐਂਡ ਗੁੱਡ ਬਾਏ।